Okay, so this is number 2 in practice 3. We'll go through 2 of each of the reactions so you can see them, okay? This one is number 2, not stupid, okay? Which was calcium chloride dissolves in water. Okay, so here was the equation. CaCl2 becomes Ca2 plus 2Cl minus. Okay, remember those are ions, right? but we don't really know about that so much, so it doesn't matter. Okay, all right, it says that the delta H is negative 213.5 kilojoules, all right? And so since it's negative, then that tells me that it's exothermic, okay? So that means that the energy equation, or the energy term, is going to be on the product side, all right? I can see that it's exothermic because the delta H is negative, okay? That's the only way I can really tell it here, okay? But some other ways I would know if it's exothermic is if that means energy is given to the surroundings, okay, coming out of the system, okay? All right, that means it's exothermic, okay? All right, and then when I make the graph, it's going to look like this. All right, down here is going to be time or reaction progress, okay, and this is going to be the chemical potential energy. All right, so I'm going to start my reactants anywhere that I feel like, really, and that's going to be the CaCl2. All right, I'm going to add energy into the system. That breaks the bonds, okay? And that's going to give me a calcium and a chloride and a chloride. Okay. And remember, that's energy in. That's what breaks the bonds. Okay. It takes energy to break the bonds. All right. And then I'm going to have energy out. And since it's exothermic, I know more is going to come out than went in. Okay. So my products are going to end up lower. All right. And that's where we're going to have the calcium that's now ion, and then 2 chlorines that are now ion. That's my products, okay? And there's also going to be energy because this delta H here is negative 213.5 kilojoules, all right? And since the products box is lower than the reactants box, I know that more energy came out than went in, okay? So this one's energy out. All right, and that makes it exothermic, right? Because just to this level here is kind of even, and then extra came out here. That makes it exothermic. Okay, more energy went out to the surroundings. Okay, all right, let me make a new page for number 3. Okay, so let's do number 3 then. Okay, that one says when dissolved in water, ammonium chloride breaks down to ammonium and chloride ions. Okay, so I have the NH4Cl, okay, is going to turn into its ions, all right, dissolving in water, all right, and that's all balanced, all right, and then since it tells me the delta H is positive 76.5 kilojoules, that's telling me that it's endothermic, okay, so it's endothermic, meaning that energy came into the system, all right. Okay, and that's going to put the energy term more like a reactant on the reactant side, okay, because I have to add energy in to the system in order to make the reaction progress, all right. I want to look at the graph. It's going to look like this. Again, I'm going to have time here, chemical potential energy here. All right, I'm going to start with my reactants, which is the ammonium chloride, NH4Cl. I'm going to put energy into the system in order to break everybody apart. So I'm going to have an N, 4 H's, and a Cl. Okay, so this is always energy in, breaks the bonds. Okay, and then energy is going to come out, but not as much as went in. That's how I know it's endothermic. Okay, so here's where it's going to go ahead and be ionized in the products. Okay. So this is energy out, all right? So the net then is overall energy went in. That's why it's a positive. Positive 76.5 kilojoules, right? Because this much came in and only this much came out. So there was extra that was put into it in order to make this reaction happen, okay? That's what makes it endothermic, all right? Some other characteristics, this would feel cold, right? Because energy in the form of heat is entering the system, okay, which means it's leaving the surroundings. So when you feel it, and if it's your hand, then the energy is leaving your hand and going into the system. That leaves your hand feeling cold because the heat left your hand, okay? Feel cold, the temperature would go down if we measured it, and the products have a higher energy than the reactants did, right? So I have to put in extra energy to make that happen.